Hello, my fellow YouTubers. Part two, electromagnetism. Let's rock. All right, so we're back over here. Transmission lines. Let's start a fresh one. Transmission lines. So you got your Tesla coil, you got transmission lines. So let's create our transmission lines. Okay. So we'll make the top one a plus, the bottom one a negative. We'll get into different setups, but right now we're going to talk about things that I've noticed, like especially from the experiment we're going to be doing here. We're going to see how this reacts in the environment of a electromagnetic field, and you're going to be pretty um, pretty what would be the right word to say? Pretty interested, I guess, on what these things do, like the gold or the silver, the copper, or the wood dust, the plastic flakes, the paper, plastic, different things I have. These, nothing's charged, so we'll get into that in a second. We'll get back over here to the transmission lines. We're going to talk about how nature works. Basically, if you look at it in a way where, say, let's not get in the way over there. Say you have the sun, okay? Happy sun. It's providing oscillating field. Okay? So it's providing to our little planet and other planets out there the oscillatory effect to the matter, which is in that space. Now we know that when you have a oscillating with a metal, what are you going to get? You're going to get electromagnetic field. And what's going to happen from there? It's going to produce radiation. Okay. So, yeah, bam. It dawned on me. Okay, so here you go. Let's expose some stuff to the sun. Let's get to the sun. It's not about the heat right away. It's about the fact that it's taking its ions and it's oscillating the ions, and it's inside of a steel beam, say, or something else that's over here, and everything starts reacting to that sun. Pretty cool, right? So if you look at it, this is just a perspective, my theory of just looking at stuff. You can take it for what it's worth. But say this is the planet, and say here's your North Pole and here's your South Pole, and basically you got to look at everything as it has a equal balance. Okay, so there's your equator. Okay, so this guy over here, you got to take the mass of it. So the mass of this sun goes from up here to up here, okay, to down there. That mass doesn't just trickle out like that, or like that, or like that, or like that. It also gets prismed like a prism and gets focused. So you're going to have a concentration of this. And I believe that's hitting the equator. That's why the equator is the hottest. And that's where the turning point would be for when you get into the inductor, like we talked about, like this inductor here. And if you would take the wire or the as the inductor and you run power, say this way, it would come up and go over this way. You would make the magnetic field go that way. And if you rotate it back the other way, you make the magnetic field go that way. So, with that being the inductor, meanings in our planet, we obviously have a blood vein running through there to create these poles like this I'm showing here with how things radiate. So everything that radiates, we have potential of picking it up or transmitting or receiving it. And it's a lot of different things on this crazy planet. Crazy amount of things if you want to think about it. Um, so I don't know on the last video if we talked about antenna designs, but a couple of the features of the antennas that you want to make sure that you're um, when you go to build your antenna, that, you're looking at, and one of them would be the just like the strength of the radiation that you're putting out in your field, and what different directions that you want to send it in. You want to send it out all around? Do you want it to be around, like basically, if do you want it to be like this and have it go out all over? That's or do you want it to go Yagi style and have it directed in one area? So that's the number one thing on building your antenna and designing your signal generator basically. And the next thing you want to look at is you want to look at your driving power. And like I was saying, on your driving power of your transmission, if it's 15,000 volts or if it's 100 watts, okay, you want to make sure you're getting a lot more out over this section. So you got to make sure you will go over it. But we're going to in this another video, but add some capacitance. You're going to add some caps. You're going to build this up, and you're going to radiate out that other side. A lot more power going out in that beautiful ether of ours. And then the next thing you got to um, add to your design of your antenna, you got to match the impedance of your transmission lines to your antenna. So once you do that, you're on your way, guys. And then another thing we want to worry about is heating up the whole damn thing. Like this right here and all this big old 19th century stuff. The stuff heats up, trust me, guys. So we want to make sure that we don't overheat it. So we want to have a system that's matched all the way through. So we'll get into other stuff. Let's go ahead and do, before I run out of damn time here. I'm looking at the time I've been spending. A couple things is, let's go ahead and grab some stuff here, glass. Let's see how this reacts. Now, it's whatever charge this is, whatever charge this glass is with the brass in the middle of it. And one thing I want you to notice is directional really matters. And we talked about that with electric field running this way and magnetic field running this way. So it's directional. And you put stuff up to it and it acts very differently when you do vertical versus horizontal. Let's go ahead and grab a piece of, this is plastic, hard plastic. Got rubber grommets on it. how this one's acting versus this one. Let's go ahead and kick this puppy on. Let's check it out with some 7500 volts, guys. Spark up. Let's go ahead and see what the electromagnetic field does. Peace out, brothers.